Volcanoes, the awe-inspiring geological wonders that have captivated humans for centuries with their sheer power and beauty. These fiery mountains have the ability to both terrify and mesmerize us with their explosive eruptions and molten lava flows. But what exactly causes these dramatic displays of nature's fury? What forces lurk beneath the surface of these majestic peaks? In this video, we delve deep into the science behind volcanoes and uncover the incredible processes that make them one of the most fascinating features of our planet. Picture this: deep within the Earth's crust, a molten mix of rock and gases known as magma is generated by the intense heat and pressure. As it rises through the Earth's layers, it forms towering structures called volcanic mountains. But the journey of magma to the surface is not a straightforward one. It faces resistance from the surrounding rocks, leading to a buildup of pressure. When the pressure from the magma overwhelms the strength of the overlying rocks, a volcanic eruption occurs. This eruption can take various forms depending on the composition of the magma and the amount of gas it contains. Some eruptions are explosive, sending ash and gases billowing into the atmosphere, while others are more gentle, resulting in lava flows that cascade down the volcano's slopes. But what happens to the magma once it reaches the Earth's surface? How does it transform into the fiery lava we see during eruptions? Let's take a closer look at this fascinating process. As magma ascends toward the Earth's surface, it experiences a decrease in pressure. This change in pressure causes dissolved gases in the magma to expand rapidly, forming bubbles. These bubbles can be quite large, reaching millions of cubic meters in volume during violent eruptions. The rising magma also encounters pockets of water, which flash into steam, adding to the gas content. As the magma continues its journey, the increasing gas pressure causes the rock to fracture, creating pathways for the magma to escape. Once the magma reaches the surface, it is no longer under the same pressure it experienced below ground. As a result, the gas bubbles expand even further, causing the eruption to become more explosive. The force of the explosion can be devastating, hurling volcanic material, including ash, pumice, and volcanic bombs into the air. These materials are ejected high above the volcano and can travel for kilometers, blanketing entire landscapes in a layer of ash. Lava, on the other hand, is formed when magma reaches the Earth's surface without significant gas content. It flows out of the volcano in rivers of molten rock. The speed and distance of lava flows depend on factors such as the slope of the terrain and the viscosity of the lava itself. Runaway lava flows can travel several tens of kilometers, destroying everything in their path. But not all volcanoes erupt in the same way. Different types of volcanoes exhibit unique characteristics based on their shape, size, and eruption patterns. One common type is the shield volcano, which is broad and gently sloping. These volcanoes are typically formed by fluid basaltic lava that flows easily, resulting in a wide, low-lying structure. Mauna Loa in Hawaii is an excellent example of a shield volcano. On the other hand, composite volcanoes, also known as stratovolcanoes, are characterized by their steep conical shape. They are formed by alternating layers of lava and ash, creating a towering, symmetrical peak. Mount Fuji in Japan is a famous composite volcano. Another type of volcano is the cinder cone volcano, which has a relatively simple structure. They are formed by the accumulation of loose volcanic fragments, including cinders, ash, and small pieces of lava. Cinder cone volcanoes are usually small and short-lived compared to other types of volcanoes. An example of a cinder cone volcano is Pyroclastic in Mexico, which erupted for only 9 years between 1943 and 1952. But what happens when a volcanic eruption occurs underwater? Submarine volcanoes, as the name suggests, are located beneath the ocean surface. Their eruptions can be quite spectacular, creating new islands or altering the shape of existing ones. For instance, the eruption of Krakatoa in Indonesia in 1883, which is considered one of the deadliest volcanic eruptions in history, both above and below water. Understanding the mechanisms behind underwater volcanic eruptions is crucial for predicting their behavior and assessing potential hazards to human activities in coastal areas and on ships at sea. Submarine volcanoes are formed in various tectonic settings, including mid-ocean ridges, hotspots, and convergent plate boundaries. Their eruptions can have significant impacts on marine ecosystems and global climate patterns. The interactions between magma and seawater during submarine eruptions can lead to the formation of unique mineral deposits and geological formations. Additionally, the study of submarine volcanoes provides valuable insights into the formation and evolution of ocean basins and island arcs. Further research and monitoring of submarine volcanoes are essential to unravel their mysteries and assess their potential risks and benefits to our planet. Now, let's explore the incredible power and beauty of a volcanic eruption through a captivating real-world example, the Mount Vesuvius eruption in Italy. Mount Vesuvius stands as an iconic symbol of Italy's rich history and natural wonders. Located near the city of Naples, this majestic volcano has captivated the imaginations of people for centuries. However, it is perhaps best known for its devastating eruption in 79 AD, which buried the Roman city of Pompeii and Herculaneum under a thick layer of ash and pumice. The eruption of Mount Vesuvius was a cataclysmic event that had a profound impact on the ancient world. The sudden and violent release of pent-up energy resulted in a series of powerful explosions that shook the surrounding region. The force of the blast was so intense that they ejected vast quantities of volcanic material, including pumice and ash, high into the atmosphere. This created a towering ash cloud that spread across the Roman Empire, leaving a permanent mark on the landscape. The eruption not only devastated the nearby cities, but also had far-reaching consequences for the Roman civilization. The destruction of Pompeii and Herculaneum serves as a tragic reminder of the destructive power of nature. Yet amidst the devastation, the eruption preserved a snapshot of life in the Roman world, providing invaluable insights into the daily lives, art, culture, and society of the time. The eruption of Mount Vesuvius is a pivotal event in human history, shaping not only the course of the Roman Empire, but also our understanding of the natural world and the forces that shape our planet. Its legacy continues to fascinate and inspire on those who marvel at its power and the enduring spirit of humanity in the face of adversity. The forces that create volcanoes are truly awe-inspiring, reminding us of the immense power and dynamism of our planet. From the fiery depths of our Earth to the dramatic displays of molten lava and volcanic ash, these geological wonders never cease to captivate our imagination. Whether witnessing the majestic beauty of an erupting volcano or learning about the intricate processes that occur beneath the Earth's surface, we are reminded of the incredible forces that shape our world. So let us continue to explore, discover, and appreciate the fascinating world of volcanoes and the wonders of our natural world. Thank you for joining us on this journey of discovery. If you enjoyed this video, don't forget to like, subscribe, and share your thoughts in the comments below. And if you want to learn more about our planet's incredible features, stay tuned for more videos. Until next time, keep exploring and stay curious.